Okay, so the workshop series will be recorded. We will be asking everyone to keep their video off until the end and keep yourselves muted just so that it's not disruptive to others. If you have questions, please put it in the chat box. I put in a link in the chat box that will lead you to a page on our website that has quite a bit of resources that our experts have shared. It will also have a link to this presentation, a link to the video tour we'll be doing a little later, as well as a link later on to a recording of this webinar. So all of our resources we hope will be in one place so that it's easily accessible. So keep that link available for now. It's not quite public yet, so it's also in the emails that I have been sending. So with that, I will pass it over to Kai, who can start us off. Kai?
Okay. Thanks, Janelle. Hi, everybody. Thanks for coming. Appreciate you coming. And we had a little change of plans, but we're going to make it work. And looking forward to the rest of the workshop series. So today is the first workshop, and it's about an introduction to aquaponics. So this is a collaboration between UH Grant, UH the SOAP program, Sustainable and Organic Agriculture Program, and Go Farm Hawaii. And together we're putting on this workshop series focused on aquaponics called GoFish. For some reason, oh, there we go. Okay. So first, we just wanted to introduce ourselves. I guess I'll start because I'm already on here, but we're gonna have Ted and Janelle also jump on in a second here. So my name's Kai Fox. I'm an aquaculture extension specialist, faculty member at UH Manoa Sea Grant College program. In this role, my job is to perform research, education, and extension as part of a newly developed aquaculture hub across the state of Hawaii and the US affiliated Pacific Islands. My efforts in this job are aimed at developing an integrated extension program related to growth, development, health, and marketing of aquaculture species of importance to community and also to importance to commercial interest, and applications to production challenges in Hawaii and the US affiliated Pacific Islands. So that's intro for me. Janelle, you want to introduce yourself, please?
Yep. Good morning, everyone. Again, I'm Janelle Yamamoto. I'm the director of the Go Farm Hawaii program. We offer beginning farmer training across the island, across the state. And we also do business consulting for agricultural organizations, companies throughout the state as well, regardless if you've gone through the Go Farm Hawaii program. So we, again, will be coming in with some business education through the workshop series. Thanks to everyone for being patient with putting this on. We hope everything will be in person. Cross our fingers on the next workshop series and beyond, but we do appreciate the interest. It'll help, I think, all of us shape what future educational opportunities could look like as well. So we will welcome your feedback and thoughts as we move forward. Ted?
Aloha, guys. Good morning. Ted Radovich. I run the Sustainable Organic Ag program with a lot of help from a lot of other guys, focused primarily on terrestrial culture. For the last 8 years or so, have been working with Kai to look at primarily vegetable performance in these aquaponics systems. So I'm also very excited to be here and to participate with this great group. If we end up back at tier 1, I'm not sure, we'll have to reevaluate, but if we kind of continue with the numbers we have, we do have options for in-person. So I do hope to see everybody in person in December, and we'll pay attention and keep you guys posted at the facility. Some exciting things happening at the Waimanalo Research Station. So we look forward to seeing everybody there at some point anyway. So Mahalo for joining, and looking forward to this series. Aloha.
Okay, mahalo Ted and Janelle. Okay, so we're gonna do an introduction to aquaponics today. The idea is generally for this workshop series is how to integrate aquaponics into your existing farm operation or to use it independently as well. Because it's an intro workshop today, we're gonna touch on some of these things you see here: system design, water quality, food safety, management, fish health, species selection, economics, but only very briefly. The following workshops will have a lot more emphasis on those. So if you don't hear too much about these things, don't worry about it. It's all coming soon. Okay. Let me see. Okay. So what is it? What is aquaponics? Aquaponics has been around for quite a long time. The name was coined in the late 20th century. And what does it mean? Basically, it's a hybridized name combining two independent agricultural systems, aquaculture and hydroponics. And I had this here as I can't seem to find my chat function, so I'm just going to go right into it. I wanted to kind of poll people. Maybe that's for next time. Where do most aquaponicists come from? Where did it originate? Was it in aquaculture or was it in horticulture? Was it from the fish side or the plant side? The answer is it primarily came and still comes from interest from aquaculturists, people that grow aquatic organisms in controlled environments. So it was developed as a way to sort of minimize the environmental impact from aquaculture and reuse some of the water and other nutrient resources that are found in the effluent waste. So, however, in recent years with modern aquaponics and commercial aquaponics, that paradigm has flipped a little bit, and a lot of commercial aquaponic farmers make the majority of their money on the vegetables or plant side. Okay, but just to dive into it a little deeper, just to get some clarity on this stuff, because that's what we're here to provide to you, is sort of distilled, accurate information. We'll jump a little bit more into what it actually means. I have this quote here from a definition from the European Union Aquaponics Hub. This is basically a cooperative network of scientists and researchers and subject matter experts from Europe and really around the world who got together recently to better kind of understand the state of knowledge in aquaponics and to kind of dig into it. So their definition, which I think is beginning to be more adopted and accepted as really a good definition, is aquaponics is a production system of aquatic organisms and plants where the majority, more than 50% of the nutrients sustaining the optimal plant growth, derives from waste, that is like the effluent water, the water coming out of the fish tank, containing the wastewater from the fish or whatever creature you're growing, the solid and sludge removal originating from feeding the aquatic organisms. Okay, so that's a mouthful. What does it mean? One of the reasons this definition is necessary is that, as Ted indicated, you can have your aquaponic system certified organic in some cases. So this is really a function of marketing. As the industry develops, you want to be able to say what is truly aquaponics and what is not. Can you have a hydroponic system and every now and then just sprinkle a little bit of fish water on it and call it aquaponics? That's where it's coming from. So does it matter if you farm aquaponically by this strict definition of aquaponics? Absolutely not. This distinction, again, is a marketing distinction as the industry develops, sort of a branding thing. So just to put that all in context. So the aqua part of aquaponics, aquaculture, the farming of aquatic organisms under controlled conditions. This is the first part of aquaponics. In Hawaii, we have a long history of aquaculture, and we continue to, both in a traditional sense, the host culture, Native Hawaiian culture, developed a very high-tech form of aquaculture in local ia, fish pond culture. And recently we've adopted and developed quite a bit of new technology, a lot of it focused in Kona at Nelha at the host park, offshore cage culture, algae culture, and we'll go into a little bit more about that in a second here. In the United States, aquaculture represents, I believe it's still the second largest trade deficit. Over $20 billion we pay to other countries for our seafood. Why is that? Again, I was hoping this would be a little interactive. Forgive me. I'm just going to answer the question. The main reason is we have really high standards for production in the United States. What does that mean? Our farmers are competing against farmers in other countries that have that do not have the same kind of stringent regulations that we do, including things like just, unregulated discharge, polluting the environment, not having to deal with your waste or overuse of resources. In terms of animal production and aquaculture specifically, the use of antibiotics is not as discouraged in other countries as it is in this country, and the issue of labor and paying a fair wage, to your workers. These are reasons why other countries have a strong competitive advantage to our farmers. So these are issues that our farmers deal with. In Hawaii, you would think that we have all the fish we can eat just around us, but in fact, we still import about 50% of the seafood that we consume in our state. So there's a lot of room for expansion. There's a lot of opportunity. We have a huge amount of agricultural land and water. If you count coastal land, we have a huge amount of it, and the potential for mariculture, which is essentially farming in the ocean, is really picking up steam in recent years. NOAA is leading the way in developing multi-use areas offshore where cage culture and other kinds of limu, oysters, that kind of stuff can be cultivated offshore. So look out for that coming. And we have so many climates throughout the islands that we can grow virtually anything. This is a kind of old school Department of Agriculture poster from the 90s, I think, just showing different products that local farmers still produce. In Hawaii, a lot of this is freshwater. You can see prawns, tilapia, Chinese catfish, some limu. So there's a lot of stuff going on, but there's a lot of room for expansion. I mentioned Nelha, the host park in Kona, right next to the airport. There's a lot of interesting stuff going on in seawater in Hawaii. There are companies that grow abalone. I'm sure you've seen some of this stuff. Catfish. I won't go through all of these, but you can see there's quite a diverse industry. There's a lot of things that are being under development in terms of R&D, private companies, and also industry and public sector, university research. Different species of fish, deep water snappers, ornamentals, and other kinds of food fish, high value food fish. So there's a lot of stuff going on, and it, as I said in the previous slide, it seems like there's an uptick in all of this in aquaculture. So it's a good time to pay attention and possibly get in. This is from a publication that Hawaii Department of Ag put out recently on aquaculture value of sales. You can see generally the trend has been increasing over the past couple of decades. We're up to a little over $80 million a year in value in aquaculture just in our state. It's pretty significant, actually. This is from the same publication, just kind of breaking it down a little bit more. You can see in 2019, the designation with D is just essentially the companies didn't want to share exact sales numbers, so they're sort of lumped into the other category. But algae accounted for a huge amount of the sales. We're talking about pharmaceutical algae, bioastin, that kind of stuff. But again, and you see the number of workers in 2019 was, just under, well, 369. These numbers have been changing, of course. COVID-19 was in 19, but the effect of COVID-19 happened in 2020. So actually part of my job is to track that rapid response, going out and speaking to farmers, aquaculture farmers, about how COVID-19 has affected their business. So here, just kind of summed up again, in 2019, that was the value, up again of about 10%, close to 10%. Generally speaking, aquaculture has increased in size as an industry globally from 7 to 10% for the past 20 years. So it's one of those industries that is continues to grow and shows strong growth. You can see the number of farms, food fish farms. A lot of the food fish farms are on Oahu or Hawaii Island in Kona. And we all know this kind of just anecdotally, but the data shows that in Hawaii we eat approximately twice the amount of fish as Americans do in the continental United States. So again, opportunities. So why is aquaculture growing? Why is it important? Just talk a little bit about that briefly. One of the reasons why aquaculture is considered one of the more sustainable forms of animal production is this concept of feed efficiency, feed use efficiency. So the food conversion ratio, the amount of pounds of feed that it takes to create a pound of meat or any other kind of product in an animal. So basically it's the amount of feed in divided by the amount of feed out. And you can see here, cattle and sheep, it takes about 8 pounds or 6 pounds to 1 pound of meat. Fish, including tilapia and salmon down here, can get very close to 1. So the smaller the number of the FCR, the more efficient it is. So you can see salmon is up to 83% feed use efficiency. It's almost a pound in and a pound out for protein. So this is one of the reasons aquaculture is so efficient. And I'm not going to go too much into this. We're just kind of touching on these concepts, but we're not, the amount of land that's available for agriculture has been decreasing significantly. We essentially are farming everywhere we can at this point, and hopefully Ted can offer some mana'o on that too. But at the moment, croplands and pastures cover about 40% of the Earth's surface. There's really nowhere else to go. So we need to start to intensify production in already existing areas because our population is going to increase significantly, especially by 2050. One of the ways that we can get towards this efficiency, this intensification, land use efficiency, is by using and developing systems like the recirculating aquaculture system, RAS. In these systems, you can have very high density, a lot of animals. You can see the tank here full of fish. These are created using artificial environment and modern materials, plastics, metals, electricity. So there is a large energetic input, both in the feed production and also the operation of it. But some of the advantages are that we can reuse water, continuously reuse water by filtering it. And the relevant part of all of this to our workshop series is that once you do this, you end up with water that has concentrated plant nutrients in it. So you can pair these systems with these recirculating aquaculture systems with plant systems, which basically is aquaponics, right? So the ponics part of aquaponics, hydroponics. Again, a soilless technique, a technique of growing plants without soil and water containing dissolved nutrients. This is a very mature industry. So the challenge in modern aquaponics is to combine the high-tech modern industry of aquaculture with the high-tech modern industry of hydroponics. That being said, I just want to lay this out here now in the first workshop series, so you always have it kind of in the back of your head. So aquaponics, so there's literally millions or perhaps infinite ways to do aquaponics, right? But it is not a technique. Okay, aquaponics is not it's not a type of hydroponics that uses fish water as a source of nutrients. It's a concept, right? You have to understand that it's a synergistic relationship between its components. So we call it also an agricultural production system, or think of it like an ecosystem. All the different parts of it have to have an interrelationship with each other. So it can utilize different techniques within aquaponics, but you don't want to ignore this concept, because you'll start to kind of get lost in the weeds, and your designs you may be off. You don't want to make it more complex than it has to be. So just understand that it's in the sense of fish, it's a complex ecosystem between bacteria, fish, and plants. Just want to lay that out there, so we all just keep it in your mind. What are some of the advantages of aquaponics? Again, we can intensify aquaponics in a small footprint. You're getting 2 crops for the price of 1. You're feeding the animals, you're getting animal protein, and at the same time, by not adding any more nutrient input, you get a plant crop. You get a vegetable, fruit, or whatever kind of cut flower crop you want to get out of it. Water use efficiency is very high. You're able to conserve water and reuse it over and over. There's no soil, so there's no soil pathogens that we know of yet. Again, this is a relatively young industry, but you don't have to use pesticides. Very high yields, essentially maximum yields of any kind of terrestrial system, comparable system, can be achieved in aquaponics. And you have a high degree of control in that production. As Ted indicated, we can do organic certification for aquaponics. You can put these things on areas where other kinds of farming are difficult to do, sloped areas, poor soil quality areas. They can be built ergonomically so that they appear nice to look at, and they're easy to use, and they can be scaled. Although this last one is a point of intensive research right now to see how it can be scaled, how big it can go. So again, not to knock any other kinds of agriculture, but just kind of putting it in perspective when we talk about sustainability. In agriculture, agriculture consumes about 80% of the water that is available to humans. The fresh water that we use goes to agriculture. So that's a big resource that's used. So I think any effort to be more efficient with that use brings us closer to sustainability. Agriculture also uses approximately 1/5 of the fossil fuel energy that's available, and this goes into cold chain, machine processing, refrigeration, transport. Also, chemical fertilizer uses quite a bit of energy to create, and also pesticides and herbicides also consume quite a bit of energy, and specifically in the form of fossil fuels. So any kind of reduction on these fronts will help us move towards sustainability. This concept, aquaponics, in its most basic form, is very old. It's not a new thing. Modern aquaponics that we practice we'll describe to you in the coming workshops, with, again, using plastics, metals, electricity, that kind of thing, is relatively new, several decades old. But this concept of using fish and plants together spans millennia in the past, from Asia to the Americas, and even local iacalo production. Briefly, there's a lot more to this, but just to kind of put it in context, the history of aquaponics, if you think of it as hydroponics and aquaculture generally together, hydroponics started using dissolved chemical salts to grow plants without soil. That concept started in the early 20th century. Towards the end and during World War II, the military was concerned with food security, And so they started to do a lot of experiments with large-scale hydroponic production, developing greenhouses, integrating, again, modern materials with hydroponics. That technology, as I said, is now a fairly mature, very efficient way to grow plants, hydroponics. In the 1970s, probably the first, when the term aquaponics was coined, New Alchemy Institute, researchers were playing around again with fish effluent water, tilapia effluent water, and trying to figure out ways to use that water again. And so the modern term aquaponics was started around then. And since then, there's been several efforts at commercializing it, both at the university level and also in the private sector. So commercial aquaponics is very new in terms of agricultural production systems. Again, very briefly, we'll get into design more in the future, but I just wanted to show this. You can study the slides. I believe Janelle is going to give you all this talk. I'll give you access to this talk. This is the University of Virgin Islands aquaponics system, commercial aquaponics system, designed in the late 1990s, early 2000s as a demonstration at the University of Virgin Islands by James Rakosi. Can be considered the basis for quite a few commercial operations. And again, I think we'll go into more detail on the system design in a future talk, but wanted to, definitely credit Dr. Rakosi for the kind of the first commercial systems. So how should you design your systems? These are just some bullet points that I think are important, and I think most aquaponic growers would agree. You want your systems to generally just be, pretty easy to use, robust, reliable, simple. Again, keep the concept simple as possible. Ease of operation. You want all your workers to be able to maintain the systems and operate them relatively easily, and have don't not have to learn, to minimize the learning curve, and to be low risk. I just wanted to, again, briefly talk about two kind of emerging concepts in aquaponics. These terms are being coined faster and faster, so I just wanted to introduce this concept so that, as you study the field, you kind of get a hold on the terminology. Again, system design will be the next workshop, but generally, if you can just bear with me here, there's two general kinds of aquaponics, and Ted put together a really cool video that you're going to see a little bit later, explaining some of this as well. But generally speaking, there's two types: coupled, which is in recirculating aquaculture system, recirculating aquaculture systems in its true sense. The fish, water gets filtered, goes to the plants, it goes to another tank, and goes back to the fish tank. The water is completely recirculating over and over and over. True recirculating aquaculture system. We call this a coupled system. In a decoupled system, you have the fish. So you have a recirculating aquaculture system on one side, the fish and the filter, fish and the filter. And then you have a sort of hydroponic system, a decoupled system. They differ in that the decoupled systems separate the water and nutrient loops of both the aquaculture and hydroponics. This provides a control of the water chemistry in both systems, right? So when you try it, and moving forward in these workshops, when you keep these concepts in your mind, and of course ask questions the whole time, but you have to keep in mind your goal, right? What are you trying to get out of this system? Are you trying to grow fish primarily? Are you trying to grow plants primarily? What's your budget like? These are all considerations you'll have to think about as you moving forward with your system design for your farm. Where it is, your location, what does the site look like? And then, are you retrofitting an old system, or are you starting brand new with construction? So all of these things will kind of play into how you decide to design your system. But certainly we need a lot more research also on these things. Briefly, this is what happens in an aquaponic system in terms of the nutrients. So calling it nitrogen transformation. There's protein in the fish feed. So we feed the fish metabolize the feed, they excrete ammonia into the water. You design your aquaponic system so that you cultivate a couple kinds of nitrifying bacteria. These bacteria convert this, so this ammonia is toxic. If this builds up in the system, it becomes toxic to the fish. So we need to remove it. So you cultivate in your biofilter nitrifying bacteria that convert ammonia eventually to nitrate. And then in your hydroponic component, the plants take up the nitrate, essentially cleaning the water for the fish, and the water returns. That's the basic concept of a coupled recirculating aquaculture system. Again, design, we'll focus a lot more on design in the future workshops, but there's several different ways you can go about growing the plants. So the hydroponic systems can be ebb and flow or reciprocating. So this is essentially a box of rocks, a box that you can see here with the clay balls and the lettuce filled with media, solid media. That's one way to build your aquaponic system. And we have some of these systems at the Waimanalo Research Station that you'll see in the future. You can also do raft aquaponics or deep water raft culture. That's over here. So that was the University of Virgin Islands style of the hydroponic component, deep water raft culture. So polystyrene rafts, typically 4 feet wide by 8 feet long. These are like foam insulation boards, holes drilled in them, plants planted in the holes, and the roots sort of extending down into this aquaponic water. And that's how it's grown. And the last one is another hydroponic technique, right? You can see here these towers, these gutters. This is referred to as nutrient film technique. It can be done with rain gutters or PVC pipes. So the fish are down here and the water is pumped up to these pipes. Different systems, different pros and cons. We'll get into that in a future workshop. But generally speaking, there's 3 components to aquaponic systems. A rearing tank, this is where the fish live, any kind of creature that you're growing, the rearing tank. Biofilter, this is where the bacteria live and where you're removing the nutrients, or excuse me, removing the waste, particulates from the system. And then the hydroponic component, that's where the plants live. Again, you can study this in a little bit more detail. I'm just going to touch on it. But when we say biofilter, a biofilter consists of 2 parts. The biological filtration, that's the component I talked about, nitrogen transformation. This is where the bacteria live. You need a place for bacteria to live so that they can convert toxic ammonia that comes out of the fish into nitrate, so the plants can take it out of the water. So part of your biofilter is this, a place where bacteria live, and then part of your filter actually physically removes solids. We're talking poo, fish doo-doo floating around in the water, solids from the system. So there's different ways to remove these particulates from the water physically from the system. So you need biological and mechanical filtration, and we'll go into that in a little more detail. The most basic design, again, we have examples of this at the Waimanalo Research Station of a aquaponic system. Again, a grow bed is where the plants live, a fish tank where the fish live, and just something to separate the 2, put one over the other. So this is the box of rocks concept. And this very simple design works fine as well. So again, it's about scaling. It's about what you want to get out of this. I won't go into much detail here, but it's very clear that there's a lot of different things that need to be addressed still in terms of research needs with aquaponics. And there are a lot of ongoing studies, a lot of really cool information. The amount of scientific papers that have been published from even 10 years ago has increased exponentially. So there's quite a bit of research in this field and a lot of interesting results coming out. And with that, I'm going to pass it over to Ted.
Awesome. Thank you, Kai. Okay, as Kai mentioned, the innovation of aquaponics has come largely from the aquaculture industry. And Kai's been at the forefront for well over 10 years at this point. And Dr. Clyde Samaru was leading the effort initially with Sea Grant and then with CTAR. And I was brought in, I don't know, around 2008, 2009, to look at the plant side, get a horticulturalist perspective in there, and really kind of look at plant health, plant quality, and optimize that side of things as much as possible. So I'm going to be showing some images here. We've done a lot of variety trials, a lot of looking at different genetics in the aquaponic systems, working with commercial growers, as well as developing the system at the Waimanalo Research Station, which we're now transitioning, and it's in the process of transitioning. And when you guys come out, hopefully we'll have some things set up to look at. So what you're looking at here is a pak choi variety trial. And if you go to the next slide, we've got reams and reams of data. And rather than put you guys to sleep with that, Kai had mentioned that the productivity in aquaponic system meets or exceeds that in terrestrial systems. And we know that now, but 10 plus years ago, I was very skeptical of aquaponics. And, I can say that I'm a convert now, database convert. This is some of our more recent work with the pak choys. We've worked extensively with terrestrial farmers, folks growing in the ground, in raised garden beds, etc. And one of those growers is in South Kona, and Tane Data and his wife Maureen, they've got a bunch of things going on, and they grow a lot of pak choi, or have in the past. And we spent 3 years working with them, and that's what that dotted line on the graph there is their average over the course of 3 years across all seasons, their average head weight for their pak choi. And you can see that our January and March data of 2017 for these pak choi varieties exceed that average. Now, to be fair, pak choi is a cool season crop. And if we were to put some of our previous summer data from 2012, 2014, et cetera, some of those numbers are going to fall below that dotted line. And so to be fair, the numbers are above the dotted line primarily because the dotted line includes summer data as well as winter, and the bars there are primarily winter yield, January and March of 2017. So when pak choi is at its optimal growth. But nevertheless, we've made the point multiple times in multiple crop species that not just yield but also quality are quite comparable. And if you're wondering what those letters are, that's just a statistical tool to tell us which of those means are significantly different from each other. So if you're looking at any bar that has an A in it, which are the first 5 there, Joy Choi is numerically the highest, but Mei Ching, Funjen, Black Summer, and Summer Boy are all statistically similar, although numerically lower. And then the San Fan and the Summer Flavor are definitely statistically lower than the Joy Choi. Joy Choi is actually a white-stemmed, heavier pak choi. Mei Ching is a green-stem pak choi. If you want to go back one slide, I'll see if those guys are in there. So Black Summer, Mei Ching. So Mei Ching is one of our favorites to grow in aquaponic systems. Funjen, you can see on the far left, is an interesting pak choi that's actually a cross between Wanbok and pak choi, and it's a nice, much lighter texture, lighter flavor, and it's much more pleasant than the others to just eat raw in salads. Anyway, we can go back to This slide and then the next slide. I wanted to keep this portion short. We got a video that goes into more detail as well. I should say I am personally a fan of media-based systems rather than deep raft systems, although economically a lot of our commercial guys choose the deep raft systems. The plant growth and nutrient dynamics are better in the media-based systems. And that's largely because there's just a lot more biology interacting with the rhizosphere, the root zone. What we're looking at here, you can see there's flowering lettuce. You can produce seed in aquaponic systems. You can grow all kinds, literally grow anything in aquaponic systems. There are some things that have a few more challenges than others, but especially in the cinder-based systems, we've been successful in growing pretty much anything. Now, economically, it's a different story, and we'll be talking about that throughout the workshops. And Janelle and I are going to be focusing, going deep on that in the 5th workshop. We can go to the next slide. So I don't know how many people have been up to the Wamanalo Research Station, up Mauka in the organic plots. We have an Ulu orchard that the trees are, I think, 5 years now, 5 years old. These are those trees 5 years ago in the aquaponic systems. We do love them for as a nursery. The tour will show you some more details. But we received these plants as tissue culture plantlets. We potted them up and put them in the cinder, and you can see that you can bury the pots in the cinder, and that'll keep these plants from toppling over, which can be a problem on benches, etc. And also they bottom feed, and so you don't have to worry about getting the water into the pot. Next slide. Shallots, like I said, you can grow pretty much anything in the aquaponics. Next slide. Okay, we've been doing, over the years, have done all kinds of things, working with Kai, Dr. Fox, and a bunch of other people. This was a public-private partnership with a Japanese company, Horimasa. A number of groups have developed indoor vertical farming based on either hydroponics or aquaponics. This is an aquaponics-based system, and they wanted us to try to grow moringa, kalamungai greens indoors. And so, yeah, you can do it. Next slide. So we did. It really doesn't make economic sense to do it, but you can do it. And so there are a lot of folks that are really digging down on the indoor, more sterile, vertical farming systems using aquaponics. So there's a lot of research on that. Next slide. And I mentioned that you can grow anything in aquaponics. That certainly applies to kalo, to taro. And the vegetative growth in taro is outstanding. There's a lot of nitrogen typically in these aquaponic systems. The minimum rhizosphere concentration of nitrate, which is the form of nitrogen that the plants prefer, is about 25 ppm for productivity. If you're measuring your soil solution nitrate concentrations, you want to see something that's 25 or higher. The concentrations in the solutions, the aquaponic solutions that we work with, obviously will vary with fish density and all kinds of things, but generally, optimally, systems that are running at optimal levels will have water solution nitrate concentrations of 100 plus. And so 4 times, the minimum needed for plant growth. So there's lots of nitrogen in there. One thing that we've noticed with kalo in the aquaponic systems is they get real vegetative, and so the lao is prolific, a lot of leaf production, but your kalo itself, the corm, doesn't get big the way it does in terrestrial systems. You can get kalo, but it's not the same way. So we've been working with community groups. Robert Wood Johnson Foundation also has funded us. This is a small part of a much larger community-based project called Malama, that's led by Jane Changdo, and who's professor at in public health, and Ilima Holastimosa, who many of you will know, who's both our community coordinator at the station and a longtime community activist, and a promoter of aquaponics in home gardens, and really took lead on that well over a decade ago. And so we're looking at kalo in these systems and manipulating water quality, basically shutting off the fish water and just putting fresh water instead, to see if we can reduce the amount of nitrogen that the plant is seeing and switch it from vegetative growth to really producing larger kalo. And we're working on that, and we're establishing a second trial of this at Waimanalo. So as we go through these workshops, you will be seeing all of that. So I think one of the upsides of the workshops is that you're going to be, kind of working with us and setting up some of these systems and learning about these systems. Next slide. Oh, hi. Same thing. I guess it was a misplaced picture at the back. Do we have any more slides? We're at the end. Okay, great. How are we on time? Oh, we're right on time, which is unusual for me anyway. I guess it's because mostly it's Kai been in charge talking. So
Hey, Ted and Kai, there's one question in the chat box if you want to address that.
Okay.
And if anyone else has questions, feel free to type them into the chat box.
You can start with ag water. I think that's one of our major focus now too, especially with our concerns about budget, et cetera, at the station. We've been using potable water. Potable water is preferred largely for food safety issues, but it's not required for sure. And if your ag water is coming within range of, for the food safety, then you're totally fine. But yes, you can definitely do ag water, but you want to pay attention to the quality of your ag water, especially if you're growing leafy greens and things that are going to be consumed raw. I don't know if Kai has some. The question was, do you need to use potable water for the system, or can you start with ag water? And I don't know if Kai wants to chime in.
Yeah, no, you answered it. That's right. Yep.
Okay. Are there other questions people have?
I don't see anything in the chat box right now. Kai, do you want to transition to the panel? We currently have Brendan is logged on and Ron. So either one, let me know and I can start their presentations.
Maybe, let's start with Ron then.
Okay.
So we're very lucky and honored to have 3 guest speakers, commercial operators today to speak with us. The first is Ron Weinebach, Hawaii Fish Company. Thank you, Ron, for coming today and speaking with us. We really appreciate it.
Well, you're welcome. Can you hear me?
Yes.
Okay.
So,
Well, I will,
go ahead.
I will, I guess, run through sort of the questions you gave me and basically introduce myself and what brought me to this point. So I'm a co-owner with my wife and 3 adult children of Hawaii Fish Company. We started the farm in 1978, initially as a aquaculture consulting company, both locally and internationally. And then in 1980 transitioned to a local aquaculture farm. As far as background, I have undergraduate and graduate degree, masters in natural resource management with a focus on fishery biology and aquatic ecology. Three of my classmates, John and Mary Todd and Bill McClarney, were the three that started New Alchemy Institute, and I believe it was 1969. They were graduate students when I was an undergrad. So I went and spent time with them in 1971, and that's where I got very intrigued in the idea of aquaponics, but it took me a long time to actually do it myself. So I'll quickly run you through my journey and then focus on aquaponics. Originally I was a fisheries researcher, starting at the University of Miami, and then at the University of Michigan. With the University of Michigan, we did a lot of international work, primarily in the Mekong Basin during the latter years of the war, and then moved over to Bangladesh. And whereas I went over there as a fishery biologist, looking at wild fish, it was aquaculture that really caught my eye, caught my interest in the Mekong Delta. And so by the time I left there, I was pretty hooked on aquaculture. I spent about a year with Pfizer of Asia, based out of Hong Kong, assessing aquaculture potential in Southeast Asia, then came to the East-West Center in '77. DLNR wanted me to help get the freshwater prawn industry started. That was a year contract, after which, during that time, I met my wife on campus, needed to figure out a way to stay in Hawaii. So we formed at that time, Hawaii Fish and Shellfish Company, later shortened to Hawaii Fish Company. I did a couple more overseas jobs in Bangladesh, but that really wasn't where I wanted to spend my life and raise my family. So in 1980, we began researching Chinese catfish, which at the time were occasionally turning up in the prawn ponds and were of concern as potential predators on the prawns. So they were always thrown away or killed. But I saw potential as a freshwater food fish. So we developed the culture techniques in my wife, or girlfriend at that time, backyard in Manoa. And you can move through the slides if you wish. So then we set up a small facility in Waimanalo, where we had our first hatchery, first pond doing cage culture, and did that for quite a few years actually, and sold the fish at the People's Open Market in Kalihi, Eva Beach, Waipahu, Wahiawa. So those were the first, you can go to the next slide. Those are the first live fish sales in Hawaii. The freshwater prawns were being sold live at that time at Tamashiro's, but this was the first live fish sales. And then we started moving into the stores, primarily the Filipino stores. To expand, we moved into Punaluu Valley, which is the next slide, and built a greenhouse hatchery so we could do catfish spawning year round. We also started raising our family at that point. And we were expanded operations to move into Chinatown at that point and diversified into freshwater prawns, tilapia, grass carp, silver carp, big head carp, all for live sales in Chinatown. And eventually that situation didn't work out. as far as land tenure. And so we moved on to Mokuleia. Next slide. And this is still in Punaluu Valley. So this was one of the 6 ponds we built that we raised fish in. And you can sort of see the divider nets across the pond that we subdivided the ponds for management. Go on to the next slide. And so we moved to an old abandoned rock quarry and started raising fish, in mainly tilapia, in floating cages. And we continue to do that to the present. But as we did our aquaculture, the price of fish feed continued to go up and up and up. And fish only digest about 30% of the nutrients from the feed, and the rest is waste. And so it either is a environmental issue you need to deal with, or it's a nutrient opportunity for growing something. At our first farm in Waimanalo, we used the effluent from the catfish pond to irrigate 10 acres of bananas, and that did very well. But that's just a single pass, so I guess that would qualify as decoupled aquaponics, but we just considered it irrigation with fish water. And then, so in 2010, we started working with Dr. Harry Yako under a USDA grant to do aquaponic trials. So next slide. Oh, this is, I'm forgetting my sequence of slides. So again, with the tilapia in the cages, we first had to set up a hatchery system to do our spawning and grow the juveniles to a size that they would be retained in the wire mesh cages. So this was our initial hatchery production site. Try the next slide. Okay, yeah, this is harvesting of our tilapia. We just bring the cages to shore and scoop them out for market. The next slide. And one of our customers up until last week, for the last decade or so, has been Alan Wong, who really worked with us to promote tilapia, change the stigma from a plantation ditch fish or alawai fish to a true premium fish if it's grown in good water conditions and given a high quality feed. And so we work very well together. Next slide. Okay, so here we are with the initial trials in 2010 with Harry doing deep water culture. This is just newly started, primarily lettuce, but we did a variety of items. I can't remember all the things we grew. But that sort of cemented our idea to move into aquaponics as we expand our farm. And so subsequently, we've just focused our efforts on trying to see what would survive in the heat of Mokuleia and in the winter salt mist that it's like a San Francisco fog that rolls in over the farm every winter, just from the salt mist from the high surf. So it's a challenging location, but we're actually doing pretty well with it. So we are currently going through food safety training under Harmonized Group GAP with the North Shore EVP Economic Vitality Partnership. And we're part of USDA's pilot aquaponics food safety program to address the concerns that some people have regarding the fish water relative to the plants and how to mitigate those issues. So that sort of brings you up to where we are at this point. As far as what we would advise for any of you that are considering going into this field. Okay, sorry, last slide, the best slide. My wife and one of our lettuce crops, We also are trying to implement integrated pest management. So we have our wasp, I don't know what you call it, but the blocks, the drilled out holes in the blocks for wasps. We have marigolds and ladybugs and so forth to help. So far, we've not had to use any pesticides of any kind, organic or otherwise. We cover our grow beds with insect netting, and then seasonally we use shade cloth according to how intense the sun is. So one of the key issues that we have been battling with from the beginning is land tenure. And so I encourage you to resolve your land issues before you go to, really before you get started. Either purchase or lease, but tie down that lease or rental arrangement, and also access to utilities. Once you move on to site, you've lost your bargaining power. And even though you're very anxious to move forward, once you put infrastructure on the ground, the landlord knows they have you, you're not going to move, and then it's much harder to get the lease finalized. That's happened to us 3 times in a row now. So we were slow to learn, but I passed that on. Recognize that also that farming is hard work, and it's enjoyable work, but it's hard. And the reward is most often personal satisfaction, not a large bank account. You can make a living, but you won't be taking summer trips to Italy or Japan. I encourage you to develop new markets for your products. Oftentimes, new farmers will go directly to markets that have been established by prior, by farmers that are already operating, and just undercut the price to get a foot in the door. And so the market never expands. It stays the same size. And the stores know that they can play one farmer against another, and it just holds the pricing down. And if we're really going to affect import substitution, we need to expand to new markets. And so I encourage you to be part of that, looking to expand into new markets. For all of the people that are in business, most of us already, that's how we got in there. There were no markets to start with that accepted locally grown aquaculture or aquaponic products. So there's an education process, and you need to help them do that. And then I encourage you to strive to be a price setter rather than a price taker. What that means is really know your cost of production, including your labor, your family labor, labor of friends. All those are at cost, whether or not you're paying or not. And as a business, you should get a return on your investment beyond your labor, as if you were putting the money in the bank or in bonds or whatever. I'm sure Janelle will go into this much more in the months ahead or weeks ahead, but remember, this is a business. And if you're not making a profit, you're primarily a hobby gardener. So think in terms of know what your costs are, ask for a fair price, and negotiate. Don't take the first offer that comes in. Otherwise, the price will just stay flat as your costs go up, and it'll just be a less and less viable farming situation. So I wish you all luck, and I'll pass on to the next person.
Thank you so much, Ron. Really appreciate that. Taking time out of your busy day to give us that presentation. Are there any, maybe one question for Ron in the chat, or maybe we can follow up later? Anybody have a question for Ron?
I don't see anything in there right now. Kai, we can circle back to the end.
Okay.
Questions.
Well, mahalo, Ron. I really appreciate it again.
Sure.
And I think did Anthony call in? Yeah.
Anthony, are you there? Someone just logged in, but not under that name, so I'm not sure if that was him.
Just text. He said he was calling in now. Okay. Sorry about this, folks. Just waiting for Anthony.
Hey, Kai, does Anthony's schedule not give him a real short window? Meaning that it's better to wait for him than move on to Brandon at this point?
Yeah, well, yeah, he said he's going to be doing a delivery in about half an hour, so he's only got he's trying to connect now. My apologies. Are there any other questions? We still have Ron on the line. Anybody has any questions, or generally maybe a question we could answer while Anthony connects?
I had a question for Ron. Ron, this is Ted. What size do you typically sell your fish at? There are some big tilapias in those images.
Okay, it depends on the market. Market in Chinatown, we typically go in the 1 to 2 pound size, occasionally 3 pound. But for the restaurant markets, they want a boneless fillet, skinless boneless fillet size. And so with Alan, we minimum of 3 pounds. He preferred 5 pounds or more. When we provided the fish to the culture meeting in 2004, they wanted really large fish, so we raised them an extra year, provided 9 pound average.
Wow.
It really depends on what the market wants. You get, the larger the fish, the better return you get as far as the consumer, the percent of yield from the fish. But for the farmer's side, the longer you hold the fish, the higher the risk. So it's a balance. And
How old is?
Changes with age.
Okay, thank you. I was going to ask, how old is a 9 pound fish?
That's a 3-year fish.
Oh, wow.
And the 5 pound fish are about a 2-year fish. And the others are, 9 to 15 months. That they don't all grow at the same size. The males will go faster than the females. In many places, they either feed hormones to make most of the fish male, or they select out the females and destroy them. But we have found that there's individual consumer preference. Some people prefer the shape of the female fish to the male fish. And so even though they're a little slower growing, we've never done the sorting for sex. We just take a little longer for the females. But yeah, there's so much variation in the customers that you go in one direction and the market will go in a different direction. That's with the fish color. Some segments want an orange tilapia, some want a dark colored tilapia, some want the spotted calico tilapia. And ironically, they all come from the same parents.
Thanks, Ron. That's great. I think we've got Anthony on, correct?
That's right. Thanks, Ted, and thanks again, Ron, for those insights. Very much appreciate it. Okay, we also have Anthony Mao on from Kupu. Are you there, Anthony?
Hey, yes, I am. Can you hear me?
Yeah. So I think Janelle has a loop of maybe some pictures that you sent of your farm. Janelle, are you able to?
Yep, I'll pull it up while he's speaking.
Okay, great. Yeah. So thanks a lot. I think just to set you up here, maybe if you could just let us know who you are, what you do, what kind of aquaponics you do, how you got here, and maybe some advice, some pitfalls, things you wish you knew ahead of time, something like that. And so please take it away. Thank you very much, Anthony.
Yeah, thanks, Kai. Aloha, everybody. I'm Anthony Mao. I currently do a mix of different types of agriculture and aquaculture. I'm here to kind of, present on what was my startup company called Kupu Place, and that's an aquaponic lettuce business, microgreens, and edible flowers. I got started in aquaculture back in 2011-ish. I was going to school at the University of San Diego for my undergrad, and then was able to travel around the world a little bit during my summer or semester abroad. And from there, I saw the need for aquaculture production through the lens of different countries and the people that were producing in those countries, namely in Asia, is like, in the Mekong Delta and Vietnam and that sort of area. There's a lot of need for farm-raised seafood. From a cultural side, they consume a lot of seafood just like us here in Hawaii, and there's not a lot of wild capture resources anymore. So you see that trajectory of farm-raised versus wild-caught. You can predict that farms are going to be important as far as fulfilling the need and that gap in seafood. So it got me all jazzed to get into aquaculture. Started working, doing finfish production in San Diego and working on more temperate species like yellowtail or hamachi. We were doing some yellowfin tuna. We were doing white sea bass and California halibut. And then I made my way home to enroll in molecular bioscience and bioengineering at the University of Hawaii, where I would end up, finishing out a project on opihi aquaculture. So I was trying to further the progression of the technology for farm raising opihi, and did a lot of system engineering, feed formulation, and so on and so forth, and did a lot of the more or less breeding stuff with invertebrates from that point on. Did a little bit of work with sea urchins, and then now I'm farming shrimp as well. With Kupu Place, it's been a focus on aquaponics though, and aquaponics has been at the frontier of accessible forms of aquaculture for people in Hawaii because of the fact that it's freshwater. You can do it in a backyard, which is more or less what my business was. And, you could even do it on a larger scale. And the fact that it's sustainable, the fact that, it touches on a little bit of more or less the ahupua'a system and the way that, traditionally things were grown in Hawaii and in Polynesia. It made sense for this place. And, one of the things that has been successful for us is, being able to produce a lot of vegetables that are not just, your run-of-the-mill vegetables, but actually for lettuce is up there as far as quality and the highest quality. So we're known for having premium lettuce that, has a lot of flavor, really good crunchy texture, and at the end of the day, I think competes with some of the best in the state. Some of the pitfalls with doing aquaponics is that, and I'm sure that some of the other speakers have touched on this or will touch on this in the future, is the infrastructure costs and the upfront capital costs that are associated with starting a farm that is above ground, or even if you're in sea pens or on coastal environments, you still need to have a level of infrastructure to cage your animals and things like that. And that, compared to soil-based farming, is on average going to be a lot higher. And then the fact that land is scarce in Hawaii has been a challenge for us. So just like how you guys are probably all envisioning starting a farm or being on a farm, in Hawaii, there's not a lot of farms currently. And the whole point of this program, I would guess, and the movement in Hawaii to be more sustainable, is to encourage youthful folks to get into farming and to develop farms. And so being part of that was really exciting. However, we're on year 3 now, producing for year 3, and things are really good on our small scale, but to expand to a larger farm, which is what we're geared up to do, is showing to be a difficult task. And finding investors versus, doing it organically with the current partnerships that we have, are big questions, like as far as directions that we want to go as a company. So that's kind of in a nutshell what Kupu Place has been about, is now balancing, we have a system that produces really good stuff. We have methods that work. How do we expand it, and how do we get to that next scale? And I don't know what the answer is at this present moment for us, because there's a lot of variables that go into it, and you guys will probably learn about those things. So yeah, just a mix of agriculture and aquaculture. But I would say I'm still in the same boat as a lot of everyone here, which is to try to get more farming going on in Hawaii.
Thanks a lot, Anthony. Really appreciate your time. I know you're kind of short on time today. Would you mind answering maybe one or two questions? We're gonna have people text a question, and maybe I'll read it out to you.
Sure.
Okay, great. Anybody have a question for Anthony?
Anthony, this is Janelle.
Hey,
Hey, how are you? I was curious whether you can share your challenges with accessing markets and like what scale those markets are at.
Yeah, totally. So our farm is geared towards direct to consumer sales. So that's, selling to individuals, and, I'm gonna go against what sort of like the traditional channel distribution idea of selling to restaurants is. They're pretty much a direct end consumer of our greens, because they actually give us a price point that is at or exceeds the direct to consumer market. Like if I were to sell it to my neighbor at a retail price. So for us, because we're small scale, we figured we could go to the restaurants because they don't need the large volume of one type of thing. They're going to look for high quality over volume. And then as long as you can match what, they would need, you might have success with setting up a relationship with that restaurant. And we've had a lot of success with the high-end restaurants. So we currently work with Senya, Rigo, Pig and a Lady, Piggy Smalls, those types of restaurants. We have a few more, but they're the ones that allow us to have a level of consistency with being able to distribute our product every week. We get orders that are what are called standing orders. So you know, we'll have, say, 20 to 40 pounds of lettuce that will go to one account ahead of schedule. And when we're harvesting, which, you know, I'm in the middle of harvesting lettuce at the moment right now. So we just put everything in the fridge and it's chilling, and I'm about to do a delivery after I hang up the phone with you guys. And that's going to be, you know, one of a few deliveries that we do every week. So we try to get our orders out same day so that our restaurants have the freshest product that they can work with, and it lasts in their fridge longer than a week. So with a high-end product, we're able to hit these high-end retailers, but we've discussed other options and have actually ventured in other options to distribute our produce. So we've worked with CSAs, a lot of the ones that you guys are familiar with through time. We're currently working on a side project with a Waimanalo Hui that is part of this CARES Act food distribution. So that's more of like a wholesale type of account where we're selling at a lower price than we would want, but in exchange for having a high volume output. And so that project is the first of what we hope to be a few per year, even though we're small scale. And the only way that we, I guess, want to expand on what we're doing in this small footprint is if we're guaranteed to have a market for it. If there's no market for the product, we're not going to push on the gas. And that's just because, you know, everything counts at the really small side of things. But as we get bigger, then we are talking about getting into potential wholesale markets, you know, distributing to hotels, distributing to potential cafeterias, and then also, of course, distributing with, say, like Armstrong Produce or like, you know, some of those larger distributors. But the cost to produce and what you need to, what profit you need to have to sustain your payroll is what's going to drive your price point. And ultimately, at a smaller scale, we can't afford to drop our price beyond a certain level. And then once you get, you know, a little bit bigger and a little bit bigger, and then if you're really large scale and you can produce thousands of pounds of lettuce a week, then, you know, we'll entertain those wholesale accounts. So that's pretty much what our marketing kind of looks like.
And I see you a lot on social media. I'm just curious, as a follow-up question, how has that played a role in your success, your social media and your branding?
Yeah, so that brings up a major point for us in what I would call our success story, is utilizing social media as like a main driver for getting our name out. And if you talk to anyone that's old school in the food distribution world, they're going to tell you that you have to market your product. And that means you're paying for marketing. I was talking to some other distributors recently, and they started to use Instagram for the first time. We have a presence on Instagram. It's not massive, but it's, for our scale, it's not bad. And this gentleman told me that he was blown away at the fact that he, for the first time in 30 years of food distribution, didn't have to market a product. That product is the, you know, the tapioca pearl drinks, the boba drinks that you get, the ice cream. He brings in those boba ice cream bars. He didn't have to market it at all, not a single penny. And he's, you know, making tons of money off of that one product. But he used Instagram for the first time. And he was kind of talking to me about it, like, you know, he was new to it. And I was like, yeah, that's how Kubu Place is driving all the sales. We're pretty much 100% on Instagram. And that's not only like the only platform or the only way that you can get your stuff out there, but it's one of the things that I think we do fairly well when I look at other farms. So yeah, that's a good question. That's awesome.
Agree. Thank you.
Thank you so much, Anthony. Really appreciate it, and thanks for letting us interrupt your delivery and taking time to share your insights. Really appreciate it.
Yeah, no worries. I'm excited for you guys to have this program. It's a long time coming. I remember putting suggestions in the suggestion box at the Go Farm event to have something like this. So thank you for having me.
Right on. Oh, I appreciate it. Thanks, Anthony. Okay, I think we'll move on to our last speaker now. Brendan Lau from Mari's Gardens. Are you there, Brendan?
Can you hear me?
Yep.
Okay.
Right on. Okay, we'll just let you take it away. Thanks, Brendan. Appreciate it.
Okay. Thank you. Okay. So, hello guys. My name is Brendan Lau. My family owns Mari's Gardens, and we've been there since 2008. Actually, a lot of people don't know that that's when we purchased that property and started our retail. I mean, our nursery production for our landscape company. Um, and then simultaneously, so in 2006, I entered the College of Engineering at and I was a mechanical engineering major um, until 2008 when I changed my mind and went into College of Tropical Agriculture for uh, an ag degree. Um, so notice that that was the same year we purchased the Mari's Gardens site. I was still going through college, and we were in a recession, and so we decided our landscape was slowing down, so we decided to try going into food production, and that's kind of how all of this started. My father and I built some hydroponic tables and failed miserably. I think we killed it like 5 times in a row. And then um, at the same time, the following year, 2009, we started raising tilapia that we caught out of Nuuanu Cemetery. There used to be this pagoda there, like 3-4 story pagoda with a pond around it, and in there was tilapia. And they called us because they were demolishing the pagoda or rebuilding it, and they were gonna drain the pond out. And so we went over there. We caught 300 tilapia, and that's how we started growing tilapia. Um, and then in 2013, we also started breeding and raising catfish, Chinese catfish. Um, some of the first guys I worked with were actually Kai Fox and Clyde Tamaru, and also Dr. Harry Ako. Those were the guys in the very beginning when we started needing extension help from the college. They were great agents at that time, and they helped us tremendously. So I think I already mentioned this, but we also do landscape and maintenance. That was our always has been our bread and butter, and that's why we have nursery space. We also produce our own ornamental plants. And so we kind of juggle a lot of responsibilities among our family. We're constantly understaffed and doing so many things. But at the same time, it's also what has allowed us to, we
Brendan? Not sure what happened. You might have to sign on again. Janelle, can you see what happened? Oh, looks like he dropped off. Huh? Shucks. Hopefully he'll be back here in a second.
I think so. Do you have his cell number to text
Yeah.
him?
Yep. I'll
Just
text
in
him.
case he doesn't realize he got dropped off.
And if he's having internet issues, he could maybe call in.
Oh, hello. Can you hear me?
Yep, we can hear you, Brendan.
Uh-oh. Oh, you can. Sorry, my internet connection is now like unstable somehow. You can hear me good though?
Yep, we can hear you now.
Oh, okay. Sorry about that.
No problem. Thank you.
So I think I cut out at we it also has allowed us to be successful in some ways because we have labor force that we can pull on, and we already own the land. And then another thing that has recently exploded is that we are doing wholesale and retail like interior plants, which is a huge fad right now. It's actually carried us through COVID because our at one point right before COVID, we were selling to a lot of restaurants and hotels, and that instantly went to zero. Um, and so we were like, oh, because for us to pivot into retail produce, it was chaos. We tried to do curbside pickup, and so many screw ups, and we had to basically develop and implement a system instantly. um but what has spawned from that is that a lot of people are coming and buying like house plants now from us, which we're selling inventory that we've been sitting on for 5 years. um okay, so what do I do in terms of aquaculture and stuff? We do several types of farming. We do hydroponics, mostly nutrient film technique, as you can see from these pictures here. But we also do a lot of ebb and flow cinder beds. And then we do some feed to waste, which is we're still using media, but we water the plants and it just drains out of the system. We also do straight aquaculture, so we do a lot of just growing fish in water with a filter. We also do aquaponics. We do coupled and decoupled systems. Coupled being grow beds directly hooked up to a fish tank, and decoupled being fish tanks with a filter, and with a float valve on a sump tank, where if the plant crop uses nutrients, then we send the water one way to that tank to refill it. And at that point, it can be amended if we choose. And then we do another type of aquaponics that similar to what Mr. Weidenbach mentioned, where we just feed water out to a fruit orchard. And that has been, as busy as we are, that has proven to be relatively effective in terms of needing a lot less labor and still producing a good amount of product out of the system. We have a fish tank that is, when we do drain the water, it flood irrigates a citrus orchard. And from what we put into it, I think we get a lot out. And then we also do just regular in-ground farming. We have plants and trees in the ground, and we do in-pot farming for our ornamental nursery production, which is just plants in dirt in a pot that get irrigated, and all of the amendments are applied like topically or foliarly by hand. um, how we got here. So I think one of the main drivers for how we got here as a produce grower is there's a definite viable market of retailers, restaurants, and consumers, just local consumers and tourist consumers who are looking for fresh, sustainably grown, local, organic produce, and not necessarily all of those in one. If you even have one of those items, you're already in the market, I think. And the market is so viable that we are able to sell our produce for a premium. um, and people, even though it's the same romaine that is brought in from the mainland, it's a completely different product. in terms of freshness, quality, like appearance, and then of course like taste. And I think that's one of the main drivers of why we've been successful in produce production. Um, and then the other big reason is that we have formed relationships with individuals and organizations that have provided every resource that was needed to get us here. We've gotten financial resources. We've had all the information we ever needed from the UH, and they've also been very helpful in doing research on their end and sharing that with us. Is priceless. Um, and also private organizations that have funded research at our site, or even just given us samples of their products to use. um, all right, and then the last part is any advice or pitfalls. One of the biggest things is that I wish that we had planned from the very beginning. If we do well, what will the entire farm look like? um because I don't think we ever intended to do this much farming. But as time went on and it expanded and expanded, it kind of created a jumble of grow spaces and tanks and things that are just not organized for efficiency had we planned it instead from the very beginning. And another one I think is in our growing systems, I wish that we this is something that we still actually don't do. I wish that we implemented seasonal crop rotation a long time ago. I've committed to working on that next year. It's such a hard process because you have to try things, and if they don't work, switch them out. So it's going to cost a lot in the beginning, but I think for long run it is necessary to operate at max efficiency. And then one of the hardest lessons that I've learned is that farming is so difficult. It will literally break your heart at times. But you know, like I mentioned before, we're producing a product completely different than, even if it's the exact same product by name. When it's brought here and compared side by side, we are producing a completely unique product. Um, um, when compared to the markets that we're competing with. And so that's one thing is that, so my advice would be to come up with creative ways to monetize your farming so that it is it's viable for you, and it's feasible for you to do it. Whether it is by marketing your product as something different, or um, even going a little further and doing things like farm to table dinners, or our tours have been huge in the past, obviously none now, but um, tours has brought a lot of revenue to us that I think we kind of you know don't take it into account in um the the income for our farming directly, but it should count towards something that helps our farm continue on. um and yep, that's all I had, Kai.
Thanks, Brendan. Really appreciate that. And actually, there's a comment in the chat that says "Mahalo to the panel for a very informative and honest talk." Yeah, appreciate that a lot. Does anybody have any questions for Brendan right now?
I have a question for Brendan. This is Janelle. Hi, Brendan.
Hello.
You guys have done a really great job pivoting when needed in your business, so kudos on that. My question relates to how have you been able to find markets for your fish, and how has that changed with COVID?
So in the past, so for our fish, we would literally just take samples to clients because a lot of the customers don't speak like perfect English. So the best way to do it is to bring it there and show them what you have and give it to them. They like free stuff. So that's one way that our main way actually of how we've picked up these customers. And the other thing is that we don't actually have that many customers. The ones that we have, they take everything we have, and there's not a lot more extra for us to go out and need a lot more buyers than what we have currently. Hello.
Hi.
Yep. Go ahead.
Sorry, did I answer the question?
Yeah, that did.
Oh.
Thank you. Kai, I
Okay.
see actually questions higher up in the chat box. Whether I think for our panelists, any major issues, challenges with disease. And the other question was, are you seeing a growing consumer interest in tilapia? So Brendan, maybe since you're on, you can do that, and then we can have Ron hop in and address that as well from what he sees.
So I see a lot of interest in consumer aquaponics from the standpoint of people wanting it for growing at their own house on a small scale. A lot of people have been buying fingerlings and stuff from us. As far as the current tilapia situation, we've been selling to Chinatown and they've wiped us out. I think it was extra busy during COVID time. So yeah, it's pretty good. I think if we could produce more, we could sell more for sure. Oh, and then there's a question here. Based on lessons learned, can you recommend better layout system for an aquaponic farm, even scalable? Yeah, I could definitely give good input on a better layout for an aquaponic farm than my own. Um, um, yeah, I mean that's something that we do is we do some consultation for people that want to build farms, and that's something that I currently do.
And I'll also chime in really quickly about that. Brendan's also being contracted by researcher in Henfast CTAR to build out recirculating seawater, freshwater aquaculture system at the UH Manoa campus. And so hopefully we can integrate that, even that sort of co-learning concept, as it gets closer to being done. Hopefully we're able to bring some of you or all of you out there to see that as well.
Yeah, definitely. If that's possible, that's going to be one cool system when it's done.
Ron, do you have any input in terms of major issues or challenges with disease that you've seen?
Well, as far as the question on tilapia, there seems to be a persistent portion of the population that absolutely won't try tilapia, that it's been ingrained in them that it's an all-alive fish, and they just are not receptive to even trying it. But I think over time that, as new people come up, younger people, and it's being, tilapia is now the #1 white fish in the U.S. as far as consumption. And it's being viewed as the sustainable fish. I think it will slowly increase. As far as taste, we've done, 10 or more than 10 or 12 years of blind taste testing with Alan Wong and with the Hawaii Farm Bureau at the state farm fairs. And tilapia prevails on, regardless of what it's put up against, at least 75% of the time it comes out on top. I think the case that I enjoyed the most was Alan had a farmer's dinner where he had ahi and opaka, big island sturgeon, grass-fed beef, and Kona lobster, and then served tilapia as the appetizer. And at the end of the night, he asked all the participants which dish they preferred. And the majority said they actually preferred the tilapia appetizer over all the other dishes. So it has the potential if it's raised in good water and given good food. It's just the stigma we have to keep pushing back on. And in time, I think the market will grow.
Thanks, Ron. I hadn't heard that story, and I have had Alan's tilapia though. It's delicious. Do you have any other questions, Janelle, Ted, or anybody?
I do see a question higher up about how big of a pond do you need to grow a 9-pound fish? I'm guessing that's Ron.
Okay. Well, we have sort of a unique situation in that our pond is 7 acres, but the water is very deep, so we have to, the average depth is about 50 feet. And so we grow the fish in floating cages. And so the cages are 8 feet. And so a 9-pound fish in low numbers can be grown in an 8-foot cage. Yeah, I really have to cut the numbers down as they grow. It's more a matter of biomass, how many pounds per cubic yard or cubic meter that the fish can be maintained in high health. We do not use any antibiotics, so we always understock our fish to give them optimum conditions, and we've always felt it's important to give the best feed we can because that's something we can control. And for the most part, the fish have rewarded us by maintaining good health and good taste. But yeah, I think you could grow a 9-pound fish in a 15-foot tank, 12-foot tank, if you maintain the water quality and gave it sufficient food.
Yeah, thanks, Ron. And we are going to touch on this concept of biomass. Stocking density is what Ron is referring to. How many pounds per fish can you raise in so many gallons of water? A little bit in more detail in a future talk also. So thank you. Appreciate that. Anybody else have questions? Well, it's just about noon, so I don't know. Janelle, sorry, go ahead.
No, I was just gonna say, If anyone else has questions, please post them in the chat box. If not, I think we can, Ron and Brendan are welcome to stay and see the virtual tour we put together. If not, thank you so much for joining us. Feel free to log off if you need to. If not, we can go to, if Ted wants to do an intro of the virtual tour, we can move to that. Or if you just want me to play that and you can talk after.
Yeah, I think I can talk after. It's just we put together with Augusto De Castro, is that his last name?
Yep.
He did a great job putting a video together last minute this week on the site. We wanted a tour of the site was something we wanted to do with the group in person. And since we're unable to do that, we thought, well, many of you are may have seen the site. Again, we're in transition, and there's a little bit of additional detail of kind of where we're coming from and where we're going at the Waimanalo site. So I guess that will suffice as adequate introduction. And Janelle, if you just want to go ahead and show it, that'd be great.
Okay.
Aloha gang. This is a virtual tour of the aquaponics facilities at the Waimanalo Research Station. The facilities were initiated in 2012 in partnership with Dr. Kai Fox, Dr. Clyde Tamaru, and some other folks to look at commercial viability aquaponics and really to focus in on vegetables, leafy greens, beets, and do research focused on answering the question, you know, are aquaponic vegetables comparable in yield and quality to terrestrially grown vegetables? We use a cinder-based coupled aquaponic system. Coupled meaning recirculating. The fish component is directly coupled in essentially a closed system with the fish and the plants. For the fish component, we use tilapia and catfish. For the tilapia, we have multiple species, black, blue, orange. We have koilapia, which are mixed and they have the pattern of koi, they're not related to koi. And then we have Chinese catfish as well. Key to the recirculating or coupled system is the bell siphon, which allows for flushing from the beds, as you can see here. We like the media-based systems. You will see throughout the course of your study different styles of coupled systems, including floating rafts and then other media types. We like the cinder because this essentially creates a soil with a living ecology that includes worms, which are top trophic level organisms, meaning that if you see worms, there's a whole host of biology and microbiology, bacteria, fungi, that the worms ultimately feed on at the top of the trophic level. So you know that if you see worms, you have a real rich, diverse biology. And then weeds, we often see weeds in our systems. And the weeds, again, speak to a diverse ecology that it really is beneficial ultimately to growing. The cinder-based systems are also ideal if you're interested in certified organic. You can get aquaponics and hydroponic systems certified organic, although some certifying agencies won't do it. But with the cinder-based systems, because organic has a strong soil focus, and the fact that you have admittedly a artificial man-made soil, but nevertheless a functioning soil with biology, with organic matter, with mineral component, which is the cinder, really helps with not just the creating an ecology, but also with the certification if that's, you know, your interest. So we've over the years have found that you can grow just about anything in the aquaponics. For example, we have this giant mamaki tree that's been growing for quite a while now. The limitation is the root zone. So in the example of the mamaki tree, once it gets very large, if you don't keep it pruned, it can get knocked over. We have transitioned our systems to largely serve our other research projects where we use the aquaponic systems to maintain germplasm, growing all kinds of things from taro to coconuts to sweet potato, and all kinds of stuff in between. A good example is ava. We've been interested in planting more ava. We do a lot of ava distribution. We have several varieties. In this case, we have Pana Eva that is very large in our system right now. We'll take cuttings from the plant. We will root them directly in the aquaponics. We will pull out the rooted plantlets, pot them up, and then put the pots in the aquaponic system to bottom feed. The aquaponic systems are nice because the cinder will hold the pot so the pot doesn't topple over. And then they bottom feed so you can have large canopy and still get water. If you're reliant on overhead irrigation, then the canopies will impede the water getting into the pots. And so the bottom feeding is really important. So for several years now, we've been using our aquaponics as nursery. And so the value to commercial systems is not just in the production itself of the fish and vegetables, but also providing other services to a commercial operation. And so on the ava, after we root it, putting it in pots, we can either distribute those large pots of ava. In this case, this pot's a little bit big, but also transplant it up into our terrestrial systems in the certified organic pots. Recent work on the continent, in the US continent, in Hawaii, other parts of the Pacific, has suggested that while the coupled systems have a lot of benefits to institutions, that perhaps decoupled systems that are not recirculating, may have more commercial viability than the recirculating or coupled systems. Currently, our area is in transition with the help of Dr. Kai Fox, who's taking lead, as the Sea Grant extension specialist. We are converting many of our tanks to a dilapidated greenhouse that's very close to the current aquaponics facility. And then the plan is to drain those tanks into a field that we've recently planted to a mixed orchard of avocado, tangerine, and papayas. And so the idea is that we have these tank fields in the greenhouse that daily a small portion of that water is flushed into the orchard system and provides nutrition. We are in the early stages. The transition will be occurring during the workshop series. So we are looking forward to co-learning with everybody and are excited to kind of discuss the possibilities with the group. We look forward to seeing you folks in person at some point soon. And I'm glad you are able to join us at least for this virtual tour. Aloha and stay safe.
Ted, do you have anything to add to that?
Nope, not at all. Just mahalo again to Augusto for filming that. And saying again that, look forward to seeing everybody on site as soon as we can.
Awesome. I'll just add that we do have our website up. I shared that link in the chat box. I also shared it with everyone in the emails. And I'm just putting it up now. Once we get to be in person, the Waimanalo protocols are here. Just want to remind everyone that we really want to be safe. So if you are not feeling well, please do not attend, as it might affect our ability to continue. The agendas I'll post up here. I will post a link to this recorded session on here as well. And Kai and Ted provided a ton of resources, which I have linked here as well. And all of our contact information is included on this page. So you will hear from us before the next session, workshop number 2, just to confirm whether we're in person, whether we need to limit the number of people who can attend, but that really will be based on what the COVID situation is at that time. So thank you again, everyone. Ted or Kai, any last minute comments? Anyone can throw in some questions in the chat box before we end. But again, thank you to everyone for participating. Ted or Kai?
Not from me, Kai.
No, not from me either. Just mahalo to the panel and mahalo to everybody for coming. That's it. Hope to see you guys soon.
Thanks, everyone. We'll stay on for a few minutes in case anyone has questions. If not, have a great Sunday.